where you can see the devices that I'm using. I use 3, and they're not all standard. We have a pointing device called our mouse, a standard keyboard, and a special key set we have here. And we're going to go for a picture down in our laboratory in Menlo Park and pipe it up that'll show you from another point of view more about how that mouse works. Come in, Menlo Park. Okay, there's Don Andrews' hand in Menlo Park. And in a second we'll see the screen that he's working and the way the tracking spot moves in conjunction with movements of that mouse. I don't know why we call it a mouse. Sometimes I apologize. It started that way and we never did change it. All right, as it moves up or down or sideways, so does the tracking spot. And the principles for its operation are quite easy to see. If you'll turn it over, Don. Can you hear me, Don? Would you turn it over and we'll see, right. Its principle is that there are 2 wheels that roll on the surface. But since they're at right angles and kind of sharp edges, one will roll and the other slide in one direction. Each of these wheels controls through a potentiometer with a voltage output sampled by an 880 converter the numbers taken in by the computer at sample times as to what the horizontal vertical components are to be of where it should put the tracking spot. And as the mouse moves over a surface, then each of those wheels either slides sideways without rolling or rolls an amount that very closely duplicates the particular component of horizontal or vertical in the net motion it makes. All right, if you take a mouse and move it through some closed trajectory back to exactly the same point, usually the tracking spot won't come back to exactly the same place it was on the screen. And for that sense, it wouldn't work well if you're trying to trace maps or other figures and diagrams. But the way we use it continuously and exclusively is to watch the screen and to follow it around. And we use this merely as a device to move that tracking spot. And your eye on the tracking spot, you really don't care whether it follows exactly this or not. In fact, we've had it at times where our tracking device, you had to move in an arc like that to make the tracking spot go on a horizontal line. And people adjusted to it and would go like that to go in a straight line and wouldn't even know that they were doing it. Other features of the mouse are that it stays put. I can lift it and replace it without having the spot change, so I can adjust where I want it for my comfort. And these control buttons on the top are used quite a bit, and I'll show you a little bit later how some of those are used. Now, the keyboard in the middle is essentially a standard typewriter keyboard except for a few special keys out on the side. The computer knows it instantly when you hit one and makes an appropriate response. This device over here is unique to us, and we always have to justify and explain it. We'll do it in reverse order. We'll explain it first. It provides for you the one-hand equivalent of what you can do with a keyboard. There are 5 keys, and normally each finger sits on a key, and depressing any one key at a time produces a character. And any 2 keys at a time also. And in fact, any combination of depressing, of which there are 31 combinations. So Don soon learns and can type a message. That is very powerful here. I went off to a file that we were working on as we were getting ready, the early parts of this presentation. And it was a message, it was something that 3 of us used a lot between us to coordinate the planning, task, contingency plans, the special needs in NLS for the fall joint, things like that. We developed a message technique so we could leave messages for each other. Under there are usage conventions, and let me just tell you about that. Underneath here, we direct messages to each other that we can unfold and see. But many times you didn't want direct messages as much as you just like to go through and leave a message for somebody. So we worked out that the conventions would be, where's an example? The convention we're going to use is that we would send a message to a guy. If I wanted to send Bill English, WKE, a message, I would put that in the file, WKE from DCE, with that pound sign in between. So any statement that's marked like that means there's a message to him from me. If I want to, I can say was also for Dave Evans, like that. So that's from me to both of them. All right, we have this thing we call a content analyzer, Jeff mentioned briefly, in which we can write expressions in a language. But we also saw, through the medium of leaving messages for each other and filtering them, that people can collaborate quite well over a period of time by working on joint files. In fact, you can have a joint file and go leave a message and get a response in a matter of minutes because they're all available instantly by anybody from one of these terminals. But there's another degree of collaboration which is very important, and which we're just going to be setting up in the next few months the hardware to do computer aid. But here we're going to set it up with a little bit of people aid too. So I'm going to establish a collaborative mode between me and another terminal. Bill Paxton's at a terminal back at SRI, and the first thing I do to do that, of course, would be say, hey, I'm going to, to call this command, we have to go into the executive mode and set executivity to a special level. Oops. And then continue with NLS. So that free demonstration of some of the versatility. All right, special command. I'd like to link to Bill, and I don't know what his terminal is right now, so I have to ask for somebody to connect me to him audibly. So Bill, will you come in through this intercom?
Hello, Doug.
Hi. All right, I need to know what terminal you're on, Bill.
13.
Okay, I'd like to have him see my text. And so this special thing, if I label 13, will switch over, so in his display he sees my text, so I'll execute it, and sure enough it does. But what's that running around? Well, if he's looking at my text, he'd like to have something to say about it. So we put on a marker, a tracking spot that he controls. So he's sitting in Menlo Park looking at this text, and he can point to it. But we've carefully reserved for me the right to control and operate on this, so my bug is more powerful than yours. But we can have an argument. Yeah. That's what they call a bug fight. So, all right. So in case you haven't been listening, Bill, we've been going through lots of examples and setting up in collaboration here so that we can go on into information retrieval. And we've set up now audio coupling, and then we're both looking at the same display, and that'd be very handy to work. We can talk to each other and point, and maybe later I could hand you the chalk on this blackboard, like saying, here, you control it. But let's stay this mode now and add another feature that hardware-wise is available through the kind of display we have. I'd like to see you while I'm working on it. So before I can do that, I'd have to set up my display in a certain way. Set it up so I see it over like that. That leaves a corner up there, and I say, now computer, do the automatic switching that'll bring in a camera picture from the camera mounted on his console, such as the camera mounted on mine is. Hi, Bill. That's great. Now we're connected audio. You can see my work, you can point at it, and I can see your face, and we can talk. So let's do some collaborating.